presenter now, right?
You're a co-host, yes.
Okay. Um, Apologies.
No worries.
I don't see an option for sharing my screen under video.
Oh, that's so strange. Look under more.
But at the very bottom, there's a green box that says share.
Oh, yeah, share button. Okay. Sorry. That's just me being I'm the guy talking about technology and I still can't figure it out.
Zoom is not something you do
Um,
very often.
okay. So in just a moment, you should be able to see my screen. And let me know
Yes,
if you guys can see my first slide here.
yes, beautiful.
Okay, very good. Okay, so yeah, today we're talking about 3D printing, and this is kind of a beginner guide for how to get started if that's something you're interested in, or just, learn a little bit about the different types of 3D printing, different materials involved, and what you can make. Um, so I'm going to cover some topics, just a basis of like what is 3D printing, a little bit of history because it's been around a lot longer than most people realize. Yeah, different types of printers, different printing methods, materials. And then I'll get a little bit into the 3D modeling and design side because that's something I actually have a lot of experience in, and that's what I do for work. It's what I did at my last job. It's what I do at my current job. And I want to, show you that it's not so scary, and you can get started and make some useful things without a ton of experience. And then, just asking that question, like, what can I make? Because there's so many possibilities. It's so overwhelming. I'll give you some ideas there. And then if you're interested, I have a little section on which printer to get because there's lots of options. Some of them are going to be a little more user-friendly than others, and some of them are going to be a lot more expensive than others. But there is a sweet spot and a good place to get started. So just to get you a little excited, some things that you can make. These are, some of these toys are like Paula was saying, like you print in place, like this octopus here. All the arms will get all dangly, and that's just a fun little toy, a little gift. A lot of people make these nice planter pots, and this one here has a nice drip tray. You can put some succulents in there. The one on the top right is actually one of my products that I sell. It's like a upgrade kit for an espresso grinder. So, people, just because it's 3D printed doesn't mean it's not like a product that you can sell, because people definitely are willing to buy 3D printed products for certain things now. On the bottom left here is probably from like a scale model of an engine, but this is actually 3D printed in metal. And we're going to touch on some metal 3D printing technology, which is very interesting. Then on the bottom right here, these are actually like custom Nerf guns. You can buy these kits where they send you the hardware, but the kit comes with the 3D models, so you can 3D print all of the printable parts yourself, and you get to assemble it. And then instead of spending, money on the entire thing, you get to build it yourself and save a little bit of money. So what is 3D printing? Everybody has a printer, for sheets of paper. 3D printing is basically, imagine if you could print every sheet of paper in a stack. So, but you're just printing one thin slice, thin layer at a time until eventually you have a full object. So it's also known as additive manufacturing. The opposite there would be subtractive manufacturing, which is, traditional machining, even drilling a hole in a piece of wood would be considered subtractive manufacturing because you're removing material to create a feature, where 3D printing is the opposite. You're only adding the material that you need in order to create your part. Yeah, materials deposited layer by layer, and it's all controlled by a computer, and typically done with a slicing software, which is something we're going to get into a little bit later. So a little bit of history. We're starting in 1981 with the introduction of UV resin printing. So this is basically using an ultraviolet reactive resin that hardens when a light hits it. Very similar if you've ever had a filling at the dentist when they stick a light in your mouth and it hardens the filling. Same kind of idea, except we're using layers of resin to create the layers of the part. 1986, introduction of SLA printing, which operates on that UV resin principle, but it's a more kind of robust system that can create the sequence for all the layers. And then that's also when the STL file format was introduced, which is interesting because the STL file format is still the file format I'm using today for my 3D printer. And that's, yeah, what the printer is looking for in order to interpret all the layers. So then introduction of SLS printing, and that's selective laser sintering, basically uses a laser and melts powder of either plastic or metal. And we're going to get into some details later on, so no need to memorize that. And then in 1989, FDM printing, that's filament deposition modeling, which is the most common type of printing that we know today, which is basically extruding, a line of molten plastic and letting it cool. It's interesting how that was kind of came to the market later, but it's the most common one we use now. And then kind of in the early 2000s, there were some open source projects that brought all of this technology into the mainstream and it made it available for normal people, where before this, it was only available to companies with like massive research budgets to develop it themselves. You're talking like millions of dollars for the same technology. And now, you can get it in your hands for a few $100. And then in 2009, yeah, the patent for the FDM printing, the patent expired. So now it's in the public domain and anybody can use it. So there's a whole bunch of different types of 3D printing. This isn't even all of them, but, touched on in the history there. We have FDM, filament deposition modeling, selective laser sintering, SLA, stereolithography, and then DLP, digital light process, very similar to SLA. And then metal laser sintering. Those are the ones that we're going to get into the most. There are a couple others like multi-jet fusion, which allows basically, it's a combination between an inkjet printer and FDM, where you can actually print color into your models as you make them, and the opportunities for colors are kind of endless. It's very cool. I think only HP has that technology, so it's very like proprietary, but it is something that is in the market. So now we're just gonna, touch on each type of 3D printing one at a time. So for FDM printing, again, this is the most common one that if you know somebody with a 3D printer, this is probably the kind they have. It's just extruding a plastic filament into little molten areas and allowing it to cool. So the most common materials are PLA, and these are all plastics. It's PLA, PETG, which is kind of like what a soda bottle is made of. ABS and nylon, both pretty common plastics for things that you buy to be made of, as well as like polypropylene. And then PVA is basically like Elmer's glue, and that allows you to dissolve the material if you want to use that as a support. We also have flexible materials like TPU, which can be very, very useful if you need a flexible component. And TPE is kind of similar, just a little bit softer. And we also have composites that will have maybe carbon fiber or wooden or metal particles kind of suspended in the plastic, and it'll give it either different mechanical or visual properties. Benefits of FDM is that it's really the most affordable form of 3D printing. It's pretty user-friendly, and you can get multicolor or multi-material add-ons that are automated, and all for like a pretty reasonable price. So definitely, this is where I recommend people start if you're getting into 3D printing. But there are some limitations, like because you're relying on the previous layer in order to add another layer. Overhangs have a limit of about 45, 50 degrees of an overhang, kind of like that. You can push it a little bit further with the right settings, but it's not as reliable. The surface finish is not super smooth. Like you're going to have those pretty obvious layer lines. The strength is non-uniform, kind of like a piece of wood where you have a grain, where wood is very easy to break along the grain, but it's very strong against the grain. So kind of similar, you got to be aware of how your part's going to be printed if you need it to be strong. Otherwise, you might make it weak by accident. All FDM materials are thermoplastics, which means they will melt when they get hot, because that's how the technology works. So if you need something that's going to sustain a hot environment, FDM is probably not a good option. And then there is also the issue of bed adhesion. When you're printing that first layer, you better hope it sticks well, because sometimes it peels up and you'll have a hard time. So big flat components can be an issue a lot of the time. So here's just a little sample. This is a pretty popular printer. It's on the more expensive side for a home printer, but it has that multi-material unit. And these parts here were printed all as one piece. Even with all those different colors, these weren't put together after the fact. This came off the printer exactly like this. So technology's come a long way. It's not paint. This is literally different colors of plastic. So pretty cool. Definitely, you know, a leap forward in terms of the quality of the prints we're getting these days. But this is kind of more what you're looking at as an entry-level printer. You know, you don't have that enclosure because that adds cost. So the enclosure is nice because it can maintain the heat inside, but it's not always a problem depending what material you're printing. The one on the left is basically the printer that I've had for the last like 3 years, and it's been a great printer, but it does take some tweaking to get it printing how you want. The one in the middle is probably like the budget pick. It's the most accessible. You know, you can get these for about $300, but they don't have as many automated features, and you're going to be tuning it and trying to get it working to your liking. Whereas the one on the right, probably the newer one from a company called Bamboo Lab. And it takes kind of the best of the both on the left here and adds some more automated features. You get that multi-material option. And it comes in at a very like accessible price point, which we'll touch on later. So those are kind of, you know, the common ones that you actually would consider getting. And then I'm just going to show many different types of FDM printers, kind of some weird stuff, some interesting stuff. This is what's known as a delta geometry. There's even, like, I've even worked with robots that have the same geometry. It's nice because they're quick. They can move really fast back and forth, but you don't have as much print volume, don't have as much strength if you need that. These were popular maybe like 5-6 years ago, and they've kind of fallen off in popularity because the more basic designs have just gotten so good. But yeah, this delta style is kind of interesting. There's also no real limit to the size of an FDM printer. Like, you can just buy these giant machines. This is not the biggest one, and obviously this guy's like, you know, pulling out. I don't know if that's a moon or a banana, but it's almost as big as him. Obviously, you know, a print like this is going to take a while. Like, it might take multiple days to print something like this, but on the right machine, it'll work. You just got to be patient. There's also different styles. Like this one prints at a 45-degree angle onto a conveyor belt. So there's no limit to the length of the part that you can print, only like the cross section. So this sword was printed in one piece entirely. And you can use a printer like this if you wanted to like automate your manufacturing. So you can imagine like printing a part and then it moves down the conveyor belt, print another part, and then you just have this constant stream of parts that are like peeling themselves off the conveyor. Which is good if you have like a print farm. People run these like on the wall, just falling into a bin. It's a pretty slick design. And then we get into some weird stuff. Like, this is somebody custom built this FDM printer to print like porcelain or ceramics, right? And they created their own slicer profiles, and you know, you allow it to dry. You still have to throw it in the kiln and put your finish on it, but you can make fully 3D printed ceramics, which opens up a lot of possibilities for like textures and geometries that you wouldn't be able to make by hand. And I think that's pretty interesting. And then, you know, we're getting to the large scale. Like, this is a house that was entirely 3D printed. Obviously the windows were added on, you know, like after the fact or in between layers, but this is kind of, you know, pushing the limits of what's possible these days. And there's actually quite a few companies working on technology like this to print affordable housing or even luxury housing just rapidly, and they're pretty robust. And it's interesting how you can kind of like incorporate insulation or reinforcement. And I think there's a patent for an extruder that puts like a piece of rebar inside of the layer, and it strengthens like as it prints, which is pretty cool. So that was all FDM printing. Everything from the, you know, the octopus to the house, that was all FDM. But now we're going to touch on SLA printing. So SLA, known as stereolithography, kind of a confusing word, doesn't really tell you what it does, but essentially what that means is it uses a projected light from below a bath of liquid resin, and then the parts pulled up vertically. And I'll get into those details a little more in the next slide, but you don't have as many options for materials because you're relying on this UV reactive resin. But you have some options like a fast setting resin, you got clear ones, you got colored ones, and you have some advanced materials like heat resistant resins, like extra tough or like ultra high detail. SLA on its own is already like incredibly high detail, but if that's your requirement, you can get some pretty impressive results. So the benefits being the high detail and the nice surface finish. You get a uniform strength, so you don't have as many like imperfections along the layers like with FDM. So that grain is not so much of an issue. And then with something like DLP, DLP basically uses like the full image for each layer projected onto the material. So it doesn't matter if you have like a tiny little section of the print bed or an entire batch on the print bed. It takes about the same amount of time to make one part as it does to make like 30. So that's pretty cool for like scaling your production. But there are some limitations. Like it's very messy. You're working with a gooey, liquidy resin that's toxic and not going to be easy to clean off of things. Requires a lot of processing. Like you got to wash the parts, you got to cut the supports off, you got to kind of sand them down, put them in a UV box to fully cure them. It takes a lot of other equipment and like a facility to make this work. So they're not great for home machines, but you can do it. And then you can only print one color at a time with these because you're reliant on the color of the resin. It's more expensive. Like resin I think is like $200 or $300 a liter, might be a little bit less, and you have pretty limited build volume. Here's a little kind of schematic breakdown of how an SLA printer works. And again, it does kind of pull the part upside down out of this bath of resin here. And then underneath, there's a projected light projecting the cross section of every layer. And this is what like a batch of parts would look like coming off an SLA printer. So you can see even here, they're looking pretty smooth, but obviously they're attached to that bed there, and somebody's going to have to clean these off and finish off the parts. Here's kind of what on the left, that'd be like a cleaning bath, probably like an ultrasonic, looks like a deep fryer, but yeah, it just cleans all the extra resin off the hardened parts. And on the right here is just removing those supports that suspend the part in the resin. Then just as a comparison, because it's a common comparison, like people are always trying to decide between an FDM printer and an SLA printer, and they want to know the differences. So this is like a microscopic view of a cross section of a layer. On the top here is FDM, so it quite literally is like strands of plastic that have been laid down. They wouldn't really be full circles like this; they'd be more squished and kind of like squashed together. But you still do get those voids and impurities in between the layers just naturally. It's hard to make that perfect. Whereas with SLA, you have these more cohesive layers that there is some, imperfections in between, but it's much, much smaller and much less noticeable. And then you can see like visually an FDM print on the left. A part like this is very difficult to print cleanly with FDM printing because of the overhangs and the curvature and how thin it is. So this, a part like this is where SLA really shines. It's kind of like a small part with a lot of detail, smooth surfaces. Definitely like a night and day difference here. So moving on to the SLS printing, which is also known as like selective laser sintering, and DMLS is direct metal laser sintering. So same kind of technology, just one is more suited for metals and the other one's kind of more suited for plastics. The plastics that you can use, these are mostly engineering materials. This is kind of like an advanced system. They're pretty expensive, but different types of filled nylon, whether it's carbon fiber or glass filled, aluminum. PEEK is like a very high-end engineering material. So it's very dimensionally accurate. It's highly heat resistant. You can machine it to high tolerances. And then polypropylene, pretty common plastic. But you can also print entirely out of metal. So you can print aluminum, titanium, steel. You can print like actual ceramics. Technically, any metal you print with a laser sintering would be a ceramic, but lots of options there for like very high-end materials for like exotic designs. And then you can also print TPU and TPE, so flexible rubberized materials that maybe won't, like, they could sustain a higher heat because um, laser sintering is a different process than um, melting with FDM. So like it can sustain a higher heat. The benefits here is like you can actually make production quality parts, especially out of metals and stuff. You got to do some finishing, like sanding them down, maybe machining something, but you have a solid metal piece at the end here. And companies do use these for some pretty interesting applications. And then obviously very strong because we're talking metals here, like carbon filled nylon. And because of how SLS works, like you don't need supports because the part is actually being buried in basically a bucket of powder. So like the first layer is just a thin layer of powder, the laser sinters it, and then another layer comes, and by the end, your part is just buried in the powder and it's supported all around. But because of that, like the surface finish isn't great. They're very expensive and they're quite messy. So here's what I was talking about, the laser actually hitting the top layer of a bed of powder. This is literally what direct metal laser sintering looks like. It's probably a long exposure here with all the sparks, but you can see kind of the pattern of the infill here. And this is just one cross-sectional layer. These machines are quite large and quite expensive, but pretty impressive. You also have some, different opportunities. Like you could imagine these are all the parts that you want to make. You could stack them all one on top of the other like this, or let your software help you, reduce the amount of volume they take up. And then the printer doesn't really care. It'll just print these however they're oriented. And at the end, none of them are attached anyway. They're just very close to each other, and you clean them off um, and they can turn out just nice. So this is literally what it looks like when you're cleaning off the parts. They're buried in powder. You got to brush them off, sand them down, clean them off. But again, these are metal 3D printed parts that would otherwise be very difficult or impossible to machine in traditional ways. So here's some example of those like 3D printed metal parts. This looks like a little rocket exhaust engine thing, engine block, some little linkages. This also looks like a piece of a rocket engine. And like as you can imagine, there's no other way you could make a part like this other than 3D printing. Like if you tried to make a cast, typically something like this would probably be sand cast, and there's no way you could get these little ports and details cast into a block of sand. There's just no way. So opens up some interesting opportunities, but probably not what you're looking into getting started in 3D printing, because this is more for like enterprise, big businesses working on high-end products. So that was all the different printers that we're going to touch on. And now I want to move into like the 3D models, the modeling, the design, and then how to actually interpret those 3D models and create a 3D print, because those all go hand in hand and can't really make use of your 3D printer without the 3D models. So yeah, we'll touch on some design tools, and I'll show you where to start. And here on the bottom right, this is just a screen capture from one of the design softwares called Fusion 360. Somebody here was designing a drone. This wasn't mine. I'm sure some of the parts here could be 3D printed, but I just have this as an example of, an assembly of a machine that you could design in this software. Before we get into the design stuff, just want to touch on, you don't need to learn design in order to use a 3D printer. Like every one of these websites here are websites that I use to find 3D models to download, stuff that other people have designed, tons of free stuff available. But you can also pay for models. Like a lot of models, they're like $1 or $5. Some of them are, $20, $30 if they're really, really complex. But you could imagine, maybe spending 30 or 40 hours designing that product for yourself, or just spend the $10 and save the time. So totally up to you if you want to download something or design it, or even just browse for inspiration. But yeah, Cults 3D and printables are probably my go-tos. But Google will show you all of these websites if you're just looking for 3D models. And here's, just an example if you're looking for a planter pot. Tons of different options from good creators. Some of these would be free, some of these would be a few bucks. But if you wanted to make a gift for somebody, and you didn't want to design it, you could just download one of these, print it in a color of your choosing, and give that to them as a gift. Okay, now we're going to get into the actual 3D modeling software. And naturally, I'm going to start here with SolidWorks, which is the program that I'm most familiar with. This is the one that I've been using for work for as long as I have been in my career. And I used it in university, but it's a highly capable 3D modeling software for both components and assemblies. Like, you can design this entire machine, and you can also make the blueprints for every single component on this machine. You can do simulations. You can make like all of these components that move, like the bearings and the gears, they all move inside the assembly, so you can verify all of that. But it's maybe, I wouldn't say it has a steep learning curve, but it's going to take some time to get used to. The next one on the list would be Fusion 360 by Autodesk. Very similar to SolidWorks, but a little bit, I would say, less. Like, SolidWorks can handle bigger projects. Fusion 360 is a little bit limited, but what's nice is they do have a free version, and it's probably the most widely used design software in the 3D printing community. So if you want to get started, I'd say try Fusion 360. It's free. There's tons of tutorials, and it's really easy to learn because of how much there is to teach you online. And then the last one would be Blender. And Blender's totally free and open source, and it's a very different type of design software than SolidWorks or Fusion 360. So Fusion 360, for example, is a solid modeling software, whereas Blender is a mesh modeling software. And I'll actually, in a moment, I'm going to actually show you each of these softwares and how they're different and what each of them is good for. But yeah, if you want to do more of like the artistic 3D modeling, like this monkey here, or if you wanted to make like an animation or a rendering or do some visual effects, like that's what Blender is really good for. It's also good for sculpting. Whereas like Fusion 360 is designed for you to design components and machines that will actually be manufactured, and it's more precise. Then yeah, just to show you, like, SolidWorks, it's not free. They do have a maker version now. The full version is like very expensive. We're talking, $5,000 to $10,000 a year per person. Fusion 360, the full version's $900 a year, which is still expensive. But I'd say, like, if you're just getting started, you don't need the full version. I still use the free version for Fusion 360 when I need it. And Blender is free and open source even for commercial use, which is very rare these days and much appreciated. So it's also a great place to start. So I actually want to share my other screen. I think I'm locked to give me 1 second here. I want to just share my window for now. And now we'll go Fusion 360. Okay. Can you guys see this new screen? Okay, perfect. So this is Fusion 360 here. This is a product that I designed that I haven't quite released yet, but I just want to show you, you have a very solid model here. The components are mated together in a logical way. These are like some moving components. If you wanted to see kind of the more 3D geometry, like what's inside here, you can switch the view. You can also slice it in half to have a look at what's going on. And this here is like a hopper for an espresso grinder, where you have this ring here that kind of seals at the bottom. You lift it up, lets them in, and when you want it to stop, you drop it down. Simple design, but I designed this to be 3D printed, and I sell stuff like this. And that's what Fusion 360 is good for. And then I will show you just real quick one of these components, for example, how you would design something like this. So you can actually roll back the entire history of the part for those features down there. And we can have a look at what actually went into making this part. So here's like a cross-sectional sketch. And we can go in and edit that sketch. And it's quite literally just like a cross section of the shape that I decided on beforehand. It's got dimensions for all the features here, and then an axis to revolve around. So if we get out of here, like it's literally just that sketch revolved around an axis. If we didn't want to go all the way around, we could grab this and just make like a slice of it. But obviously we want it to be solid here. And you can, you can look back and see where all these features are coming from. It's kind of one thing at a time till you have it where you want it. Then you can create a pattern. So, I patterned that one feature all the way around. Maybe another pattern, and now we have everything we need here. And then, yeah, designing with the assembly in mind, putting all these components together. Then as a comparison, just going to switch my screen here again. So I have another software to show you. And I think you should be able to see this new one. Perfect. Okay, so this is Blender. You can see it's very different, and there's a lot more stuff going on here. So this here is literally a light. This is like the camera. Here's another light. Put in a backdrop here because this is a scene where we can render something that's more like a visually appealing. So if we wanted to let it run, like you can actually see the shadow and some transparency and like the surface finish of the part. This would have kind of like a painted surface. You can wrap images around it. This is more visual. Like you can do animations, you can do renderings, but you can also see, if you just wanted to see like the wireframe view of the whole mesh there, these are all elements that you can grab onto and move around. The entire thing is editable. You can scale it up, scale it down if you want to select the whole thing. I don't know if I can even select the whole thing, but yeah, you can scale the whole thing up. You can scale it down. You can do all kinds of adjustments to the base mesh of this model, which is just different from how Fusion 360 and SolidWorks work with more like sketches and dimensions. This is more artistic. Fusion 360 is more for like engineering. So I'm going to get back to my presentation if I can find it. Okay, yeah, that was 3D modeling software. So we covered 3 options. Again, if you want to get started in designing useful things, try Fusion 360. If you want to make like an artistic thing, like I don't know, a frog ornament, Blender. So now to make use of your 3D model, you need a slicing software. And the slicing software is basically what takes the 3D model and creates the instructions for the printer to do its job. The printer doesn't know what to do with a 3D model without slicing it and interpreting that information based on what the printer is capable of. All 3 of these softwares are kind of based on the same open source code. Prusa Slicer has been around the longest. That's the one that I use because my printer is made by the same company, Prusa. And then Orca Slicer is probably a more advanced version of the same program. You get more options, although that'd be a little bit overwhelming if you're just getting into it. So Orca for advanced users. But for the most part, I'd recommend Bamboo Studio because the printer that I recommend most people get into is a Bamboo Lab printer. And Bamboo Lab is nicely polished software. And pretty much all of these can be used for any brand of printer, whether the settings are like preloaded into it or you have to just add the size of your printer and the size of the nozzle and your gear ratios and stuff. There's ways to do it, but ideally you want a software that's designed around the printer that you're using. So whatever brand of printer you go with, try their slicer software, probably going to get you the best results. And then, yeah, I just want to show the slicer software because that's pretty interesting. Paula, nod your head if you can see this one. Okay, perfect. So this is what the slicer software looks like. I have just, a tray of parts here. This is exactly what the tray would look like in my printer. It's the same dimensions. So if something is outside of the boundary here, then it's not going to be able to print. And then we can show the sliced view. So this is now we've generated all the layers, and I can show, every single layer coming down. There's an instruction for what's going on here. If we zoom in a little, you can see like the pattern of the infill, and all that can be changed, like the number of perimeters here, the density of the infill, the pattern of the infill. And then we can also show, like, again, because this is the instructions for the printer, you can see every single tool path the printer is going to make for every single layer. So if you want to see like what's the order that all this material is going to be put down, you just drag this bar here and you can see that for every single layer. And then sometimes you'll need like support material. These parts, you don't need it the way they're oriented, but let's say you wanted to like orient this in some awkward way, just floating in space. You can still do it. You just got to put support material, which is kind of auto-generated. Sometimes it looks pretty funky, but it's going to do what it needs to do in order to support the part. You got lots of settings and parameters to adjust this sort of stuff, but I just wanted to give you a little example of what that looks like. Just going to switch back to the presentation. Okay. So you're a 3D modeling expert, you have your printer, you know how to slice your models. Now, what the heck do you make, right? There's so many options. I just have a few shown here. Like I really love the custom tools that people are designing and like the organizers, either for your tools or you can make for your cutlery or for whatever hobby you're into. If you need organizers, 3D printing is great for that. You can make actual useful tools. Like I made some woodworking tools, corner clamps and drill guides, all sorts of little stuff that you could go to the store and buy and spend all this money, or you could get it for like a quarter of the price in your home, or you can make something specifically for your needs. And who knows, somebody might have already designed what you need. So check online and you could probably download a lot of tools. You can also design your own products. Like I said, I have a little Etsy store where I sell some very niche like espresso gear. But whatever you're interested in, like whatever projects you have, if it's useful to you, it's probably useful to somebody else. And you could print the product and sell it online. You could put the 3D model that you designed up for sale. Lots of stuff you can do here. And the place I recommend most people start if you want to learn design, like go either replicate something you have or try to repair something. Replace a broken piece, something that you can measure. Maybe it was a bracket, maybe it was like the handle off your coffee mug, something around your house that you could imagine like fixing. Try fixing that with design. So take some measurements, mock it up in Fusion 360, print a prototype, see how it looks, and iterate from there. And it's really satisfying when you repair things or solve some problems in your own space using 3D printing and your own designs. You can also make decorations. Like people love to make Christmas ornaments, or you could make like a candle holder. You could probably make a menorah if you wanted to. Or you can make just those little toys and gifts and doodads. I've made a whole bunch of lamps, and you can make night lights. You can make planter pots. You can, or you can find the octopuses and the dragons online and print those for your friends and their kids. And yeah, like, your 3D printer is really a gift machine. You can just make as many gifts as you want instead of going out to buy some silly thing for $40 that was probably made for $2. You can just make it yourself for $2 and customize it to the person you're giving it to, and they'll love that way more than something that you went out and bought because you made it for them, right? These are just some random examples. On the left here is actually kind of a cool thing that the Bambu Lab printers can do with the multi-color. This is like a 2D image, but it's printed kind of like the stained glass, and it actually has that color when you shine a light through it. Or you can make the monochrome ones with a single, like just a white material. Yeah. So now you're wondering, what printer do I get? There's so many options. The budget pick that I'm going to recommend is the Creality Ender 3. They now have the version 3, which I'm sure has some improvements. still around $400, but I wouldn't recommend really spending any less than that because you're going to end up spending a lot more in upgrades to get it to where you need it to be. And these things work right out of the box generally. Next one, be the one that I really recommend you get, which is the Bamboo Lab A1. You have the option of getting that multi-material unit there if you want multicolor. It's about, yeah, $630. I think maybe that's the sale price, so maybe it's normally like 700. You can get it less than 500 without the multi-material, and you don't really need it. It's totally up to you, but these ones have they're quite fast. They have a lot of automatic features, and you'll be printing within 15 minutes. Their slicer software is also very good, so if you just want to use the default profiles, it'll probably work for you. And then, if you have a little bit of money to throw around and you want something a little more advanced, you can look at the higher end of the home devices like the X1 Carbon here. This one can print really fast. It can print carbon fiber. It's got some extra features on the touchscreen here, like vibration canceling. And the enclosure is very nice when, especially if you have a drafty space. Drafts can cause like warping on your print. So having a heated enclosure will make your prints a little more consistent and reliable. So I'll leave you with this. 3D printing is not, as automated as these machines are. You're going to deal with this. I've dealt with a spaghetti monster like this many times. You're going to have failed prints. Your print, it's not going to fail in the first 10 minutes. It's going to fail 20 hours into a 21-hour print. And then, that's just part of the fun. So pay attention to how your prints look when they come out. See, pay attention to how things change when you tweak settings in the slicer. Do some research about like different materials and temperatures and layer heights and different nozzle sizes. I'm not going to get into those details today, but yeah, I just wanted to show you some perspective. It's not always perfect. You're going to have some struggles and failures, and that's just part of the fun. So that's it
Wow.
for now. I hope some of that was interesting to some of you.
Gosh, Ranen, you absolutely blew my mind. You blew my mind. Wow. You're such a good teacher. Can you stop sharing your screen? Then we'll see everybody and see who wants to speak and to
Absolutely.
yeah, awesome. Oh my goodness. That was really exciting. I learned so much and you gave such a beautiful overview. Lance. Hey.
Look at Lance.
Nice. Good to see you, my friend. All right. I'm going to check into the chat, see if anyone. Oh, so Arlene was also blown away, and she's
Arlene's here.
Incredible. Woo. Oh, Ginny asks, what's the maintenance and durability issues for printers?
Honestly, I've had pretty good luck. Like I didn't have to do any real maintenance to mine until very recently. The one piece I had to replace was just like the heater in the head of the printer. There's like a heating element that heats it up. And I accidentally shorted mine out and sparks flew out. And I thought I totally fried my printer, but it was like a $5 part. Replaced it in about 10 minutes and now it works fine.
Wow, well done.
Sometimes you get a jam and you got to learn how to solve that. I've had a spool kind of like fall apart mid-print or things get tangled.
Sure.
But for the most part, like if you don't get that super budget printer, it's probably going to work. And if it does break, it's probably pretty easy to figure out. You can just repair it yourself.
Amazing. Over to you, Mark.
Ronan, that was miraculous, awe-inspiring. Ronan, I remember you, I don't know, from 35 years ago, and you were storming up, a little guy storming up and down the
Not quite 35. Not quite 35. He's not even 30 yet.
Okay, whatever. But Ronan, this is awe-inspiring. I congratulations. I have a couple of questions, if I may.
Absolutely, please.
I'm sitting here watching this on a Lenovo X Carbon laptop.
Mm-hmm.
And I got it because I tend to drop these things, and it's really, really strong. Was it made with printing, the case?
No, definitely not. That computer, as far as I'm aware, yeah, they just cut that top piece out of a sheet of carbon fiber. which would be generally what you want to do with carbon fiber. Like printing carbon fiber isn't the same as having like a weaved sheet. So weaved sheet's going to be way stronger, at least in like, all
So
of the
would that,
directions.
the same question apply to, because we started off with hockey. Hockey sticks and hockey masks, the goalie mask, are they made with printing or not?
No, I don't think
No.
they would be. Something like that. You also got to realize like 3D printing, while it is very capable, to use 3D printing for production is very expensive. So if you're making like something like a hockey stick, they're making like 1 million of them a year, right? It's worth the investment for them to make the molds and the tooling in order to do those in the traditional way, because economy of scale, like it makes more sense. But let's say you were only making like 5, you, instead of investing $50,000 in a stainless steel mold for your carbon fiber, maybe it's better to 3D print it. Something like a hockey stick, probably maybe, you know what, with a big enough printer, if you could print it on its side, it might actually be strong enough. But if you had to print it like the tall way, I think it would snap.
I have a question as well. Hi,
Sure.
Renee. Thank you for your talk, which went way over my head. I'm gonna ask a simplistic question. When you have a 2D printer, you have to provide the paper.
Right.
And so if with a 3D printer, do you have to provide the material that's going to come out in?
Absolutely. Yeah. So for something like an FDM printer, you literally have these spools of plastic, and it's just like a thin filament of plastic, and that gets I mean, these printers are essentially a glorified hot glue gun on a motor. It's just, imagine you squeezing a stick of hot glue and you just put it in layers. It's literally that, just really tiny and automatic for an FDM printer.
So that's plastic, and can it also do metal?
That style can't do metal because
Okay.
you'd essentially be welding, right? You would need like 2000 degrees to melt the filament. But you can get like metal impregnated plastics. So there's like metal particles. But really, if you want to do metal 3D printing, you'd want that laser sintering printer where instead of extruding, like it works on a different principle. Instead of extruding the material, it shoots a laser at the bed of like powdered metal. So the laser gets really, really hot, and wherever the laser touches, it hardens that metal powder, and then it creates a metal object.
I mean, I had been told that you can 3D print a gun that works. Which is
Yeah, I don't think you could
very
print the
thought.
barrel, but yeah, people print as far as I know, like the only regulated component of a gun is the receiver. And a lot of guns, the receiver is already made of plastic, like especially on a pistol, even on the real ones, it's not metal, right? So the idea that you could 3D print one is not hard to believe. Yeah.
Lance, over to you.
Hey, Ranen, it's been far, far too long. Great to see
Hey,
you.
Lance, thanks for joining.
Super interesting talk. I've got a couple questions here. The first, building on your last point about these failed builds, for the slicing software, how much guardrails are in place to sort of try and prevent that, or does it really come down entirely to sort of user experience?
It will warn you. So a lot of the failures that I've had were they're usually caused by that bed adhesion issue of your first layer. So like, let's say you make a really wide part and the printer, like my printer doesn't have like a camera where it's monitoring what it's doing. The Bambu Lab printers actually do have cameras, and it has a machine vision. So if it sees a warp happening, it might actually warn you. But mine isn't that smart. So if the corner starts to peel up, eventually it will collide with the head of the printer, causing a crash. It might break apart, like it might detach the part from the print bed, and then it'll just be moving around. But the printer doesn't know. So then if you're running a printer overnight or you're not home, you end up with that like spaghetti monster because it's just printing onto nothing. It's just extruding, and it just becomes like a fluffy wig kind of. You also could have a jam in the nozzle. Like sometimes the dust that collects on your spool will collect in the nozzle and just cause a jam, or from the factory that made the plastic. Maybe a metal shaving got stuck in there and it jams the nozzle. And again, some printers have a way to sense that and just be like, hey, I'm jammed. And other ones, they will just keep trying to print, expecting that the material is coming out and not realizing that it's not. But yeah, if you go for a Bambu Lab printer, like if it does fail, it'll probably warn you. But the cheaper ones, they have no way of knowing. So they just keep trying.
Okay.
Rhonda,
Interesting.
Hey,
Mama.
I
Okay, and
remember when not too long ago, one of your nozzles broke and you had to reprint it. Like you were able to print
What?
the piece you needed for your printer.
I don't think I printed a nozzle.
Well, I
Does the
don't
noz-
remember what it was, but it was an attachment thingy that got clogged up and you had to fix it, and you ended up printing the new one.
Yeah, no, I think you're getting like two different scenarios confused, because like I did have a clogged nozzle and I did have a worn out nozzle and I had to replace that. That's not something you can print because it's made out of metal, like brass, and it needs to be really smooth on the inside. But I have printed like attachments for my printer, and even out of the box, a whole bunch of the parts are 3D printed. Because Prusa, like their whole vision is to create a factory that makes 3D printers, and the factory is filled with 3D printers. So it's essentially like printers printing printers. That's their whole philosophy.
What came first, the chicken or the egg?
Yeah, exactly.
Ranen, Ginny asks in the chat, how long does it take to print, for example, a planter? You pick the size. Let's say like a
Yeah. So okay, let's say something like here's a little planter like this. It really depends on a few factors. Like the main one is what's your nozzle diameter, which will determine your layer height. So with a standard nozzle, something like this, probably 6 to 8 hours. With a larger nozzle, which is what I like to use, closer to like 3.5, 4 hours. It reduces the time, and if you don't need that added detail of a really tiny nozzle, then sizing up, will save you a lot of time. But then with like a really fine nozzle, if you wanted those details, it might take like 10, 15, 20 hours, but it'll look really nice in the end.
Ranen,
Go ahead.
I have a question.
Sure.
Or a comment, I should say. And my comment would be to anyone looking at watching this, it's fine to create something that is a trinket or a gift or something along that line. But I would caution that if anyone were doing this and it's something, let's say, safety and or security related, I would do a lot of research to make sure that whatever it is that you manufacture wouldn't somehow compromise someone's safety and or security. So
Are you
that
talking
would be
about
the
car
only thing
parts,
I would
Kevin?
be concerned about. More
About car
the
parts?
more the structural integrity of whatever the
Yeah.
material is, so that it could withstand some intense use that would not compromise and cause the part to fail and jeopardize someone's safety.
Yeah, I mean, at the end of the day, if you have like a high load application or like a high, if you're expecting something to fatigue over time, you're not going to want to make it out of a plastic that has like a lot of impurities in it. But there's certain things like, F1 racing teams and like SpaceX, they're using 3D printing for race car parts and rocket parts, and they're able to optimize the geometry of their design to withstand the forces in the exact like directions that they expect it to occur. And then of course they're doing a ton of like testing, like torture testing of their prints. You don't just print something and hope it works. Like you print a test part and you break it and see like, was it sufficient, or do I need to revisit the design?
Yeah, exactly. And that's what I mean. I wouldn't think that someone would make something and then just start to use it and jeopardize the integrity of the part in order to just have it made, so to speak.
Mm-hmm. And like usually when I work on a project, like I always expect it to go perfectly the first iteration, and then 2 days later I'm like 8 iterations deep, and I almost have the part that I want. So there's always an opportunity to destroy your first couple versions and see like how are they failing.
Exactly. I
recommend
guess that's
everybody.
Yeah, that's what I'm getting at is like,
Yeah,
yeah, test it and make sure if you're going to make something structural or something that could perhaps, compromise your safety and or security, that you make sure what you've done is going to withstand its intended use.
absolutely.
3D printing of the house just completely blew my mind.
Yeah, yeah, it's pretty cool.
Yeah.
And they've been trying it longer than you think. If this is kind of your first introduction to that, like there's different systems that different companies are working on. I wish I could have, when I was looking for the pictures that I picked, like there were so many, and I could have just made the whole presentation about that.
Well,
But I definitely, I encourage you to look into whatever area of 3D printing you're most curious about. If it was the houses, like do a Google search and see what's out there. It's pretty impressive. They can do entire developments
So
in
Renan, can
very
I share
quickly.
something with you?
Sure.
I last year bought an Arai helmet. It cost me approximately $800 for this helmet, and a part on it malfunctioned and broke in such a manner I couldn't use the internal tinted visor that the helmet was built with. And I contacted the manufacturer, and they wanted to me to send the helmet back into them first to determine whether it was something that they would cover under warranty, and if it was not under warranty, they had a minimum service charge of $100 plus shipping back and forth to the manufacturer to resolve the problem. I contacted a friend of mine that has a 3D printer, showed him the part, a very small, about the size of your thumbnail type of part, gave it to him. He replicated the part, and for probably 50 cents worth of plastic, resolved the problem for me, as a favor, basically.
Yeah, and that's a great way to use 3D printing again, is like repairing things, right?
Yeah.
For a big company like that making these helmets, I've had that issue too with like mountain bike parts, where it's like some tiny little plastic piece broke and they want $30 for this thing that I could literally print for 30 cents.
Yes.
And 90% of the cost is just logistics. Like it's all the people at their computers who need to type away in order to get that part to your door, and all the shipping, right?
Yeah,
Somebody had to
yeah,
package it,
exactly.
and just that labor increases the cost substantially. So if you have your own printer or you have a friend with a printer,
Yeah,
it's much more accessible to just repair things yourself.
absolutely. And it
And parts
saved
aren't
me
always available either, right? For something old,
exactly. Yeah,
sometimes you just can't get them.
yeah.
So
No, it was exactly what was needed, and he replicated the part perfectly, actually made it slightly modified it slightly so that it would work even better than the
yeah, you can make it better.
original design. And I've used it dozens of times and still working perfectly for probably 50 cents worth of plastic. Yeah.
Exactly. That's great.
Renan, it's like you hired Kevin to come and give it.
Yeah, I planted him in the audience.
Well, I get it. I get it. I understand the many applications, and I probably deal with and see it every day. Yeah.
Hey, Renan,
Yes.
I really like the planterns, so we need to talk.
Very good.
We'll get you set up.
Bruce dropped into the chat. Thanks for explaining such complex technology so well. I think you're an amazing teacher, Renan.
Thank you.
Yeah, really amazing. I think you should do this again with just you and make a YouTube for people to learn about this, because I think it's a really amazing overview, and
Thank
we
you.
all learn so much. Just want to thank
Absolutely.
you so much for doing this. And Lance, someday a presentation.
Yeah, we need a
Not
physics
Lance
class.
Kowalski. Yeah. Okay, you think about that. Thanks to everyone out for coming. This is the end of our next generation, and we're going to gather again at the beginning of June. Actually, the end of May. Yeah, Arlene says yes. Make a YouTube. We all want to
I'm
see
on
it.
it.
All right.
Great presentation. Amazing.
Thank you so much.
Thanks
Yeah.
everybody
you.
for joining.
Yeah.
Hope you learned something
Very,
interesting.
very informative.
Congratulations.
Thank you.
Thanks,
you.
Renan.
Thanks, Renan.
Cheers,
Okay.
everyone.
Have a wonderful weekend, everyone.